Okay, so as we go through these examples, they're just going to get sort of progressively a little bit more and more difficult. In the first example, it was just straightforward, area between two curves, upper minus lower. In the last one, it was a little bit more difficult, not only just sketching the curves, but also we had to go and find the intersection of the curves, and that is what gave us the limits of integration. Okay, so just going back and remembering, we needed to figure out what these points were because they became our upper and our lower limits of integration. So fine. Now this one is also going to add something that's a little bit more complicated. We're looking for the area bounded between sine x, cos x equal to 0, and x equal to pi over 2. So let's first just take a look at what this looks like. And so we have our setup. Let's take a look at cos x. Okay, so cos x, we know that cos of 0 will be 1, and it's also going to cross over the x-axis, let's say right here at pi over 2. So cos x is just going to sort of come down like this. Okay, that's going to be cos x. And then we have sine x. So sine x is going to start here at the origin. And at pi over 2, it's going to be equal to 1. So it's going to pass through this point right here. Okay, so let's see if we can do this in a decent way. Maybe that's going to be our sine x function. And this is cos x. And we want to find the area between these two, but also between x equal to 0 and x equal to pi over 2. So for this, we get the vertical line right here, that is x equal to pi over 2. And we also have this line x equal to 0. So what is the line x equal to 0? Well, that one's actually a little bit weird. It is going to be right here. It's going to be the y-axis. That's x equal to 0. So what's the region, or what are the regions in this scenario that we're looking at? We're actually looking at two of them. The first one is right here. Okay, and the second one is right here. So now we're not just looking at one region, we're looking at two. But nonetheless, the same theory applies if we go and actually look at a sample rectangle here. We can set it up vertically, knowing our base width is going to be delta x, so we will be doing everything here in terms of x. So fine, let's go and set up our area. So it's going to be the integral of the upper function minus the lower function. That's always the same if you're integrating with respect to x. And my limits of integration will be from a to b. Now here, we have to ask ourselves, what is the upper function? Well, on the rectangle that I've drawn here, it's pretty clear the upper function is cos and the lower function is sine. So that's going to be fine. I have here cos of x minus sine of x. Upper minus lower. And my limits of integration are going to be what? Well, you have to realize that the way that we've drawn this, yes, we have two different regions, but the statement that the upper function is cos x and the lower function is sine x, that is only valid from here to here. Okay, there's my upper function cos x, and there is my lower function sine x. But immediately after this point, okay, we have that our upper and our lower function switch places. We end up with our upper function being sine x and our lower function being cos x. So that's seemingly a bit of a problem, but it's actually not too bad to take care of. All we have to do is treat it as two different regions, treat it as two different areas, and so two different integrals. The first area the first integral, will be the one that we're setting up right here. The upper function is cos and the lower function is sine. Now, what are going to be the limits of integration? Well, the smallest value of x here will be 0. That much is clear. But the largest value of x we need to find. The largest value of x is actually going to be determined by this intersection point right here. So let's take a look at what that's going to be. We need to know what is the intersection between sine x and cos x. So we have, when is cos x equal to sine x? Now, some of you may just know this. You could look at a trig table. You could think about using your calculator. One way, though, is actually to think about, oddly enough, the tangent function. Here we can say sine x divided by cos x must be equal to 1, and so really we're saying tan x must be 1, and that's going to end up giving us x equal to pi over 4. Okay, so that intersection point right here is pi over 4. We end up with x equal to pi over 4. Okay, that's the intersection from 0 to pi over 2 at least. So fine, that's going to determine here the upper limit of integration on our first integral. And here, let's just be clear. This whole thing, this is going to be A1, where A1 is the area of that first region. We also want to look at the area here of the second region. Let's call that A2. And we need to figure out what is going to be A2, and then we're going to add the two of them together. So fine, once we've done 1, we know very much what the process is going to be. And we know that we're going to start off this second integral at pi over 4. Okay, they're starting right there. That's the smallest x value on the second interval. The largest x value will be here, pi over 2. And we're going to do upper function minus lower function, but we know the upper and the lower function switched places, so now it's going to be sine x as the upper function minus cos x as the lower function. We again are going to, we're going to integrate here with respect to x. And so now we want to figure out what those two areas are and add them together. So the first one, antiderivative here of cos x, we know that's just going to be sine x. The antiderivative of negative sine, that's going to be positive cos x. And we evaluate all of this from 0 to pi over 4. Fine, let's go to the second one. We have antiderivative of sine x is going to be negative cos x. So let's actually do this a bit nicer. It's going to be negative cos x. The antiderivative of negative cos will be negative sine x, and that needs to be evaluated from pi over 4 to pi over 2. Okay, so now we're just going to sort of plug everything in and see what we end up with. So the first one, we have sine of pi over 4. That's going to give us 1 over root 2. And then we have plus cos of pi over 4. That's going to be the same thing, 1 over root 2. And then we're going to be subtracting sine of 0, which is 0. And cos of 0, which is 1. So that's the first part. Now we go over here to the second part, and we have negative cos of pi over 2, so that's just going to be 0. Then we have negative sine of pi over 2, so that's going to be actually minus 1. So we have 0 minus 1. And then we're going to be subtracting what we get when we plug in pi over 4. So here we have minus cos of pi over 4, so that's going to be, again, 1 over root 2, but this time it's negative because it's being subtracted. And the same with the sine x term. We have negative 1 over root 2. And now we just want to bring all of this together. So we do have here double negative on both of these terms. So actually, let's just sort of fix those. Okay, these are all going to be positive. So what we end up with then is just going to be 1 over root 2 multiplied by 4. And then we have here a minus 1 and here another minus 1. So we end up here with minus 2. Now, we could simplify this. I am just going to leave it as is. Okay, that's going to be the area of the region bounded between sine x and cos x. And then also bounded between here x equal to 0 and x equal to pi over 2.